Class 11th Chemistry, Unit 7 Equilibrium, and in this video we will discuss about equilibrium involving dissolution of solid or gases in liquids and general characteristics of equilibria involving physical processes. First we will discuss the equilibrium involving dissolution of solid or gases in liquids, and in this we will discuss first solids in liquids. Only a limited amount of salt or sugar can dissolve in a given amount of water at room temperature. If we increase the temperature, this amount may be increased. In a saturated solution, no more of solute can be dissolved at a given temperature. The concentration of the solute in a saturated solution depends upon the temperature. If we increase the temperature, this concentration may be changed. And this amount of solute in a saturated solution at a given temperature, this is called solubility at that temperature. Okay. In a saturated solution, a dynamic equilibrium exists between the solute molecules in the solid state and in the solution. If we take the example of sugar, see this diagram. If we prepare the saturated solution of sugar, then in this situation there is an equilibrium between undissolved sugar in solution and dissolved sugar in solution, and this can also be written like this: sugar at solution is equilibrium with sugar in solid state in that solution. Okay, and at this equilibrium, rate of dissolution of sugar is equal to rate of crystallization of sugar. Equality of the two rates and dynamic nature of equilibrium has been confirmed with the help of a radioactive sugar. Now, this two rate means rate of dissolution and rate of crystallization. Now, what is this radioactive sugar? Sugar whose molecules contain radioactive isotopes of carbon, hydrogen or oxygen is called radioactive sugar. Normally, sugar made out of carbon-14 or oxygen-16 is known as radioactive sugar. Normal or regular sugar molecules without any radioactive isotopes of carbon, hydrogen or oxygen are called non-radioactive sugars. I think you are familiar with this term radioactive. Okay, radioactivity. This is the phenomena of radiation of alpha, beta and gamma rays. Okay, any substance which emit these radiations is known as a radioactive substance, and this carbon-14, this is the radioactive element. In sugar, if normal carbon, that is carbon-12, is replaced by carbon-14, then that sugar is known as radioactive sugar. Okay. Now, first of all, we have achieved the equilibrium in non-radioactive sugar. Now, if we drop some radioactive sugar into saturated solution of a non-radioactive sugar, then after some time radioactivity is observed both in the solution and in the solid sugar. Clear? Initially, there were no radioactive sugar molecules in the solution, but due to dynamic nature of equilibrium, the dynamic nature means the sugar which is present as a undissolved, this will dissolve, and the sugar which has dissolved, this will precipitate out. This is the dynamic nature, and due to this dynamic nature of equilibrium, there is exchange between the radioactive and non-radioactive sugar molecules between the two phases. The ratio of the radioactive to non-radioactive molecules in the solution increases till it attains a constant value. Now, we discuss the equilibrium when gases dissolve in liquids. Okay. When a soda water bottle, you are familiar with the soda water bottle, is opened, some of the carbon dioxide gas dissolved in it fizzes out rapidly. Now, what is the meaning of this fizzes out rapidly? यदि आपने सोडा वाटर बोतल को खोलते हुए कभी देखा है तो एक सीटी जैसी आवाज, सनसनाहट जैसी आवाज के साथ में कुछ गैस बाहर निकलती है. Clear? This is the meaning of fizzes out. The phenomena arises due to difference in solubility of carbon dioxide at different pressures. Actually, in sealed soda water bottle, carbon dioxide gas is filled at the high pressure. As soon as it is opened, then pressure is decreased. That's why some carbon dioxide gas which is dissolved, it will out. Okay, and this result in this fizz is out. This result in this sound, सीटी जैसी आवाज उसमें से आती है. There is equilibrium between the molecules in the gaseous state and the molecules dissolved in the liquid under pressure, and this is represented like this. Carbon dioxide in the gas phase is equilibrium with carbon dioxide in solution in that soda water bottle. And this equilibrium is governed by Henry's law, which states that the mass of a gas dissolved in a given mass of a solvent at any temperature is proportional to the pressure of the gas above the solvent. If this pressure is more amount of gas will be dissolved. Clear? But temperature should constant. If we change the temperature, this will change. This amount decreases with increase of temperature. The soda water bottle is sealed under pressure of gas when its solubility in water is high. As soon as bottle is opened, some of the dissolved carbon dioxide gas escapes to reach a new equilibrium condition required for the lower pressure. This is how the soda water in bottle, when left open to the air for some time, turns flat. यदि सोडा वाटर बोतल को आप खुली रख देंगे, सेम सिचुएशन आपके पास सॉफ्ट ड्रिंक जो बोतल होती है आपके पास उसमें भी आता है, उसको यदि आप खुली रख देंगे, इट टर्न्स फ्लेट. नाउ व्हाट इज द मीनिंग ऑफ दिस फ्लेट? A flat soda has no bubbles. That is, whatever the amount of carbon dioxide gas is dissolved, this will escape from that bottle. Okay. Now, summary of equilibrium in physical processes. In the previous video, we also discussed some physical process when phases are changes like solid liquid equilibrium and liquid vapor equilibrium. Okay, and in this video we have discussed that when solid is dissolved in the liquid and when gas is dissolved in the liquid. Just see what we have discussed. For solid liquid equilibrium, there is only one temperature, that is melting point at 1 atm, at which the two phases can coexist. That's why we can say melting point is fixed at constant pressure in solid liquid equilibrium at 1 atm pressure. Okay. For liquid vapor equilibrium, the vapor pressure is constant at a given temperature. For dissolution of solids in liquids, which can also be represented like this, the solubility is constant at a given temperature. For dissolution of gases in liquids, okay, this can also represent it like this. The concentration of gas in liquid is proportional to the pressure of the gas over the liquid, or simply we can say this ratio, that is concentration of gas which is dissolved divided by concentration of gas in gaseous form. This ratio remains constant at a given temperature. Simply we can say each physical equilibria is characterized by the one fixed constant. Okay. General characteristics of equilibria involving physical processes. Equilibrium is possible only in closed system at a given temperature. Both the opposing processes occur at the same rate and there is a dynamic but stable condition. All measurable properties of the system remain constant. When equilibrium is attained for a physical process, it is characterized by constant value of one of its parameters at a given temperature. We have just discussed. Is it clear? Each equilibrium is characterized by the one constant value of one of its parameters. The magnitude of such quantities at any stage indicates the extent to which the physical process has proceeded before reaching equilibrium. Okay. Thank you. Subscribe my channel to get the new videos from this chapter.